Welcome to our Tech with Founder. So now the topic is a third year core domain roadmap for our EC students. See, for our EC students, we have created a third year a roadmap from beginning of the third year, like from campus to corporate wise. So like here we can see that. See, you are still now entering into a third year, and you are confused to choose which side, like which domain to choose, which subjects are important, how companies are going to hire, how to prepare for placements, might be what questions asking in the placements. You have studied for sem exams, right? That too enough for sem exams. While coming to placements, what we should learn in advance, what should we learn? We all see right now here. Okay, right, very well. Like now, today I'm going to explain here what domains are available in our EC branch and which subjects are the most important subjects. And next, how to start from basics to and how to go for advanced, basics to advanced, and step by step towards a best level preparation. In our basically in our EC branch, there we have two sides, core side and ID side. But today I'm going to tell you about core side. In our core side, we have lot of the domains like VLSI domain, embedded system domain, IoT domain, communication system domain. Today we will discuss about VLSI domain, right? All right. See, these are the domains which in core side and ID side. Okay, right? There are two domains in ECE, core domain and software domain, two sides. Today, but I am going to tell you about core domain. Moving to domains, the biggest mistake every student going to done like is they study for only exams. They do not understand in depth of concept, and they do not keep interest on conceptual learnings. See, companies don't ask about your marks. Like, did you got 80 marks or 90 marks? They just ask your concepts. They just test your concepts. They're going to ask. They test you. Did you understand the concept or not? Right? See, major domains in the core domain are VLSI design, embedded system. Today, I'm going to tell about you VLSI design. In VLSI domain, there are two sides. One is digital VLSI, analog VLSI. First, I will say about you digital VLSI, right? Digital VLSI, very well. Digital VLSI, I'm going to tell you about. Basically, while moving to digital VLSI, first these are the subjects, main core subjects in our branch. Okay, right? This is the digital VLSI proper road to road roadmap. I will explain each clearly. See, when you choose digital VLSI, you should focus on a digital electronics and logical design. Before that, you learn network theory uh, and basic subjects because it was basic questions you might be asked from them. After learning those basic subjects, you come to the main major part of digital VLSI, digital electronic logical design, digital circuits. You must learn these all concepts. If you prepare for GATE, it's very well enough because in GATE you will go in depth of the concepts. There might be you can get very well knowledge about the subject or what may be concept. You can get very well. So this is what here. This is what about the subject, the main mini major subject. Okay, now you are choosing digital VLSI and learn the digital circuit subject. And next, coming to that. Okay, now coming to after learning digital VLSI, we should focus on a Verilog HDL. See, there is a this is simple like that. Verilog HDL means for CSE students, they having a language like Python, C++, C, Java. For IT side, for IT domain. While coming to code domain, this Verilog HDL is a type of language for us in our code domain. ECE, it's a type of a language for us. Verilog. Here we use it to compile what we have studied in digital electronics, like suppose taking an off add, writing it inputs and output, and assigning the inputs to them and getting output. This is the mean by of Verilog HDL. In this Verilog HDL, you you should make a you should be a master. You should learn very well. You should learn very well of in-depth of concept Verilog HDL language and after make it as a practice of coding. You see, you people think there is a no website for practice. For C students, they have a lead course to practice, right? Hacker ranks. For our EC students also, there are websites for practice, like Verilog HTML. You Google it, Verilog HTML, or you may search it, Verilog HTML. It will be display a practice codes, right? You can practice it and you can get a rank of certificate there. It's very well. And after completing this Verilog HTML, do the mini projects like based on the electronic subject we have done off address ALUs. There's a mini projects. After completing Verilog HDL, you come to FPGA basics. See, in Verilog, after there will be system Verilog also. That good. But Verilog is enough. System Verilog you should check basic, right? Okay, now coming to FPGA board. See, here you might be have a doubt. What is mean by FPGA? See, while coming to FPGA, it is a field programmable semiconductor. Sorry, it a field programmable gate array, right? It's a semiconductor chip that can be programmable or reprogrammable. It's a semiconductor chip. It can be programmable or reprogrammable. Our wish. We can write and erase. That our best. Okay, based on the manufacturing only. See, it is used to the FPGA board is mainly used for to perform digital operations like what you have studied in your digital electronics. Here you can implement it. Simply understanding while coming to simply understand about FPGA. See, think FPGA like a blank digital hardware board. Blank digital hardware board. You can perform it like ALU, processors, control system, control traffic systems, vending machines. You can make different projects on this board. Okay, this is a well known about FPGA board. And next, see, um, the FPGA is going to use in industry is for testing hardwares and the prototyping cleanings, right? After learning this FPGA, learn RTL design. RTL design is might be a register transfer level. You might be have what is meant by register transfer level. See, it is a way of designing. It is the language. It is the way of designing digital circuits. How you can check here how data moves between registers and what operations on the data using during clock signals. See examples. For example, I am going to say that suppose a register A stores data, register B stores data. By combining this, by adding this, a register C give the output and a clock edge output. This entire operation is called as RTL design. Okay, I hope you understand about RTL design. This entire operation is called as RTL design. After this, come to verification basics. You might be have what is meant by verification basics. See, verify means you know verifying it very well. See, why verification basics means you have written a Verilog code or RTL code to check that code is right or wrong or right or not. So we use this verification basics like logic corrections, timing verifications, clock verifications. We use this verification basics, and here there is a test bench. While coming test bench means it is a see, test bench is coming in advance. In Verilog you are going to study about test bench. They're little basic, and you need a complete test bench studying means you come to advance of Verilog means advance of Verilog is system Verilog. See, you might be have a different, you might have a question. What is difference between Verilog and system Verilog means? See, Verilog is mainly used for digital logic, digital circuit designings, RTL coding, FV design. By using Verilog, we can design ALU FSMs. You might be have FSM final state machines, right? Counters and more. Now, while coming to system Verilog, the system Verilog is an advanced language or advanced extension of Verilog. Here you can perform a advanced operations while comparing to Verilog, right? It is mainly used for verification, test bench development. See, I think you hope you are not understand what is meant by test bench. Test bench. See, I'm going to tell you now. In general, a test bench is a simply controlled to check something works properly before you are going to use in the real world or you are going to use in the real world. It is a none but it is a test bench means if you're going to check while you written a code and implement on a hardware description language board, FPGA board, before implementing, before you are releasing into a market, you're going to check is it working or not. So it was called as a test bench, right? See, while coming to reality, in industry use, Verilog is used for RTL coding, FPGA projects, basic digital. System Verilog is used for ASIC verification, UVM, and advanced. Right now, coming to yeah. Before I was forgot to tell you one thing. It is a static timing analysis. It is one of the most important topic in digital VLSI. Those who choose a digital VLSI role learn that also static timing analysis. It is nothing but it's a mathematical representation of clock signals. It is a physical representation. It measures the signal outputs, right? Fine. These are the roles available in digital VLSI as per the companies. I have displayed you all what roles are available as per the companies, right? See, this right now in a VLSI we have two domains. One is for digital VLSI, another one was analog VLSI. See, most of the students are going to choose 80 in 100 and 100%, 70 to 80% students are going to choose digital VLSI. Why? For why I'm going to tell you later, right? For furtherly moving now, analog VLSI. See, digital VLSI deals with ones and zeros. It's already it is all meant to be digital, like binary numbers. Coming to that, okay. But analog VLSI always going to deal with a continuous signal, right? Right. See, while you choose the analog VLSI, you should focus on network theory, basic subject, analog electronic. Well, coming in order: network theory, electronic device and circuits, signals and systems, control systems, higher electronic knowledge. You should focus better in analog electronics and electronic device and circuits, and after little bit communication systems, little bit EM waves, right? Okay. See, this this syllabus is the main head of this analog VLSI. If you prepare as per gate, as per the deep of the knowledge, you may have better basic knowledge, right? This is the a major head of this analog VLSI, right? After learning these, we move to CMOS technology. See, basically in analog VLSI, CMOS is the foundation. CMOS is the foundation for a chips manufacturing or IC design in analog VLSI for semiconductor manufacturing, right? Here NMOS, PMOS, you all know that you are going to study all about these in a basic subject electronic devices, and after that you are going to study in well in analog electronics also. And after completing this, you should master in this subject. You are going to master in this subject while in CMOS technology, right? After this, these are all the analog important topics. Okay, now while coming to learning, after learning the basic subjects and after mastering the analog electronics, electronic devices, and a CMOS technology, and next you are furtherly coming to analog layout design. For a digital VLSI, they are going to have what it called as Verilog, system Verilog, RTLs, FPGAs. For analog VLSI, we have analog layout design. See, a layout means nothing as a physical implementation of circuits on a silicon board or a board. We are going to implement it in physical, right? There where there in coming to digital VLSI, they are going to type as per the codes, right? Okay, this is the a basic skill in analog VLSI. After that, you all completing those what basic subjects, electronic devices, analog and analog layer CMOS technology, analog layer design. After coming to that, you should practice what you have learned in these tools. Okay, LT Spice, it is a beginner tool. It's a very basic, very basic. You can understand what happening in that circuit simulations, analog waveform analysis. After completing that, you come to cadence. See, this cadence tool is going to use it by in industry. Okay, it is a very important and a basic. It's not a basic. It's a very important advanced tool, right? Cadence. You may have questions from these tools also, right? You should focus very well on these tools also, right? After that, learn analog design flow. It's nothing but analog layout design only. In this, you are going to learn advanced, right? See, might be you all know MOSFETs, BJTs, IGBTs, JFETs. But in industry, before 1 year, I think before one year, these FETs are introduced in industry. FinFET, GAFET, HMET, JFET. These are the new FETs. Might some of the institutions are take this in evolve this in their regulations. Some are not evolved this. See, you should learn this also because the questions are coming from this also because know what uh, trend going on industry, which FETs are using. You might be have a questions from this FETs. Learn FET operation, not only FET operation. How what is happening in that FET? Why that FET? What is the advantage of that FET? Comparing difference between FETs, right? Next, like blocks in analog IC design. These are IC designs. How what happening? You learn this. No, fiscal design. Fiscal design. I have tell you that analog design after like Verilog, it has advanced planning system Verilog. For analog VLSI, layout design, analog layout design. After mastering, after completing that, you should master physical design for a PD. It is a role. It is a, you see, you should do. It is a role in analog VLSI. You know that, right? After that, I will show you. See, this is all after mastering analog VLSI. See, in digital VLSI, you have a lot of steps. In analog VLSI, you have little bit steps, but somewhat difficult to conflict it, right? In analog VLSI, these are the roles which was offered by different companies. And next, coming to these are the all simulation tools for our EC branch students, right? You may check here. See, LT Spice, I have discussed it right now only, and advanced tool I was not included in this. See, these are all our semiconductor companies in India. After completing this all, you may check what companies are available for us right now. See, right, I told you that why 80% of students choose digital VLSI, right? Because in digital VLSI there is a proper, and proper means there might be somewhat simple, like easy understanding. While coming to analog, you must go deeper. You must understand very deeper knowledge, very deeper concept subjects. See, while choosing your domain, understand between the digital VLSI and analog VLSI. Most of the students, I have said that choose digital VLSI, but there is a difference. See, who are going to choose analog VLSI remains one of the most respected one and high skill domain in the semiconductor industry. See, whatever it may be, students with strong analog fundamentals are always highly valued. That what secret behind analog VLSI. That what. Thank you all. I will share the resources in next video about this, and I'm going to tell about an embedded systems in next video. Thank you all.